Good morning. Welcome to Digital Logic Circuits. My name is Muhammad Al-Athamne. I'll be your instructor in this course. I'm a postdoctoral fellow at Auburn University in Electrical Engineering Department. I did my PhD in Auburn, graduated in December 2022, and did my master also in Auburn as well, graduated in 2020. I'm originally from Jordan, which is a country from Middle East. I raised and born there, did my bachelor and master there as well. Then I came to the United States in 2018, started my graduate school journey until graduating in December. Through my study, I was instructor of two courses, Fundamentals of Electrical Engineering and Digital Logic Circuits. I was instructor of Digital Logic last summer. Now this is my second time. I also have working experience. Before I came to the United States, I was working with the electricity company, and while I was working there, was part of industrial there. Then I find myself, this is not the place that I want to be. I was more interested in academia. Then I decided to go to the graduate school, and I found my place. Okay, this is the right place that I want to be. So being as university professor is more suitable for me than working on industry. Therefore, that's why I'm here. So I'm working toward this goal. So now let me go to the course syllabus. You can go here to Canvas. You should have an access to the homepage. So you can see here the course syllabus. So here is information about my email, the office. So the office in Brown 157 and the lab Brown 152. These are next to each other. Most likely you will find me in the lab. I will be most of the time in the lab. But there's the lab and the office here. The office hours, Monday and Wednesday from 1:30 to 3 p.m. In case if this time does not work for you or you need to find me outside of the office hours, I'm very flexible. So make sure to send me an email. We can set an appointment. And so we can meet at any time that work for you and work for me as well. In case if you cannot come in person and you need to make a Zoom, that's fine. We can make a Zoom meeting if you need to, if you cannot come to my office hours. The best time, or the ideal time to reach me is direct after class, so in this classroom. The TA, here's the TA email and the TA name. In case if you need anything regarding to the grades, please reach to the grader, to the TA. Anything related to the grades, anything related to the course, reach back to me. When you go to the grader and let's assume for some reason you are not satisfied with, for example, the grader grade, or you're finding the grading criteria for some reason, or you think I need more points, I deserve more points, or you need something, then reach back to me. I'm every time in your side, even if the grader is not grading, if grading in some way, but you still have a point of view, please reach back to me. I'm very flexible in this case. The textbook, you should have an access to the textbook online. You can click on the name here, then it will go directly to the textbook. Uh-oh, come on. I think it should be available here in person level. Yes, so I will fix the link later, but you can find it here in Pearson. You can find it here. When you go there, just open Pearson, so you should see the textbook here. So it's online, and there is a fees for this will be charged in your e-bill. If you have the hard copy or if you don't need it, you can opt out at any time. Basically, there is some instructions written in files. Here, e-textbook all access, so you can see if you need to opt out or if you have any other questions or any other inquiries, you can find them here. If you still have any problems, you will see I think a name, a contact phone, so you can reach back to him and for any inquiries about the textbook. I think there's a deadline. The default, it will be charged in your e-bill unless you decide to opt out. The deadline, I'm not sure if maybe 1 week from now. So you should see the instructions here. So you can have access to the Pearson level here. I will try later. I will fix this link so you can open it by pressing this button. The course objectives. Most likely, this course will be separated into two levels, so 2 halves. The first half going through combinational logic circuits. The second half sequential logic circuits. This course is cumulative, so if you are not understanding combinational logic circuits, you will struggle a lot in sequential logic. And it will be start easy and getting more complicated step by step. So it's like climbing the hill. So if you need to make sure that you understand the basics, the foundations, so when you go to the next level or to the next lecture, it will be fine. Then don't make this course like crowded on you, or don't make it, don't wait and say, I'm gonna study on it on the weekend. The summer is busy, so we have 3 classes every week, and there is also 75 minutes each lecture. So I encourage you to start or to study for each lecture. Study, like after today's lecture, go back home and study for it. So don't leave until the next lecture, or don't keep it later. Don't leave it until the quizzes time or until the exam days, because it will be very hard. But if you understand everything and you are up to date, it will be fine. So in order to be on the safe side, please don't make sure to study it step by step. If you have any questions during the lecture, please feel free to contact me. If you find or if you see this question will take so long, or you still need a lot of clarifications, feel free to stop at my office at the office hours or by making an appointment. So prerequisites of this course, I think like basics of the computers. The topics, we will go through introduction to digital systems, today's lecture, then we will go to numbers, systems, Boolean, switching algebra, switching functions, canonical forms, circuit, minimization, kernel maps, design of combinational circuits, then modular design, encoder, decoders, multiplexers, demultiplexers. So until here, this will be for combinational. Then for the sequential, we will go to some like latches, flip-flops, registers, counters, sequential circuits, analysis, and designs with some examples. Then if we have time, we might go through programmable logic devices. I'm not sure if we have time. It depends. Most likely in the previous time, I didn't teach this because there was not enough time. I'm not sure about this summer. We will see how's the progress. I will not go so fast, so we'll go to make sure we will go step by step and everyone is understanding the concepts. This is the thing that's I'm trying to focus. So it's very important to make sure that you are understanding this course very well. And it should be fine. It should be all right. The grading policy. There will be quizzes, weekly quizzes, homeworks, exams, and final exam. So the quizzes weight will be 15 points, homeworks 10 points, exams 20 each for the first, second one, final exam 35 points. And the final exam is cumulative, which will cover everything. The grades ladders are shown here. The quizzes, I think it will be 7 quizzes. I don't know why I write 5. It will be 7 quizzes. The exams duration will be in Fridays. First exam in June 16, second exam in July 14. The final exam in August 4, already been assigned there. So you can see the quizzes. The first quiz will be in Friday, May 26. And second quiz Friday, June 2nd, and so on. So you will see all of the quizzes, all of the exams will be in Fridays. So you should expect to see in each Friday something, like it can be quiz or exam. Except there is, I think, in June 23rd, because it will be the final of the mini summer, so there will be nothing. So this is the only Friday that will be off. So these 2 Fridays, which is this week Friday, there will be nothing. And in June 23rd, there will be nothing. These 2 Fridays. Otherwise, you should expect to see something. The homeworks times will be different. So depending on how's the progress. So we'll see like a homework and due dates in May 29th, there is June 5th, and so on. So you will see that the dates of the homeworks can be different than the quizzes. What I encourage you to be in the safe level, you can go here in the announcement I published. There's something called Add the Canvas calendar to your Google calendar or to your Outlook, iCloud, something like that. So when you add this, you can follow these instructions. Then you can know when's the deadline for each one. So you can know, like, okay, in the following Monday I have maybe homework and so on. So you should be able to see it by looking at the calendar. So it will be more helpful in my point of view. I prefer to have this so you can remember what will happen. Okay. Now I'm gonna just go a little bit to the assignments. So here in the assignment section, you will see homeworks, quizzes, exams, and final exam. So all of the dates are assigned here as well. So you can see them on the assignments. In the assignments here, you will see homeworks 1 to 8 homeworks. Each homework will start a certain date. So you cannot submit homework 1, or you will not know what's the content of homework 1 before May 22nd, and so on. So there's an opening date, there is a final date. Keep in mind that, like, for example, the first homework from May 22nd until 29th, you have almost a week. And some of them, like, you have 4 or 5 days. So there is, this time I put this time in purpose because we need to make sure we already covered enough material, and you need to do this job in this time. Okay? Most likely the homework will be some problems from the textbook. So, for example, like homework number 1 here, you can see it. When you open it, you will not have an access to it, but this is an example, like 1.1a, 1.4, and so on. So starting from May 22nd, it will be open to you. So what you need to do is to start answering. You can submit it in the same day, in May 22nd, that's fine. You can submit it in the deadline. Make sure, don't pass the deadline. There will be no late accepted. So after this deadline, it will be 0. Unless you have an excuse absence for something, for some reason, this will be a different scenario. But otherwise, no late homework will be accepted. You have enough time and you already have this. The homework, don't submit it in paper. The homework, you can write it in paper and scan it as a PDF, or you can do it on the computer, whatever more convenient for you. The submission will be on Canvas. So basically, you will go to Canvas and you will go to submit. You will see a submit button here. All of the homework submission and the quizzes as well will be on Canvas. The exams are the only thing that you need to turn them in paper. So that's for the homeworks. So the reason for the homeworks, because I want to encourage you, or even like force you to study for the course, because this only the lecture notes will not be enough. You need to practice more. The more you practice, it will be more easier for you. Then it will be when you go to the quizzes, it will be easier, and when you go to the exams, it will be easier as well. The exam or the homeworks grading will be now something different. Will not be the TA will not grade the homeworks. Who's going to grade the homeworks? You. How? I will assign anonymous grading. So the Canvas will choose person that you will not know in this class and will grade this quiz. It will grade, the exam, the homeworks. This is only for the homeworks. The quiz, the exams, the TA will grade. So basically, what will happen, after the deadline, that's, for example, the first homework, the deadline is May 29th. So in May 30, you will receive an email, like invitation to review or to grade this homework. So you will grade, maybe you will know the person who will you grade in, but that person will not know you. So, for example, I will grade your your homework, and you will not know that I'm grading yours, so it will be fine. And it will be randomly. So we have 8 homeworks, and we have around, I think, 6 or 18 students or 16 students. So most likely you have a 50% chance to rotate for the half of the class. So when you make this grading, please, for the grading, I will publish the answers. So it will be guide for you to do the grading. And please try to make sure to be flexible on the grading. Don't make it too hard, because if you're being too hard, maybe the other guy will be hard on you. So try to be like fair enough. So this is the point for the homeworks. And the weight, I think it's 10%. It still matters, but I mean, I want you also to be interactive. Why I want you to, the homeworks are just like to practice, for you to practice, and the same way, I want you to look at the others' mistakes, and you can learn from them. That's my point. However, for the quizzes most likely has higher weights, and the exams, of course, so those are very critical, and the quizzes will be in 10 minutes. It's not like the homeworks you have 7 days or 1 week. So for the quizzes, of course, it will be the TA will grade this. Okay? Then for the grading, if you are, or for the homework grading, if you are unsatisfied with the person who grades for you, and let me say that he was very hard on you, then you can write in the comments, I object on this grade. I think I deserve more points. So it will be, I can fix this. Okay? So if there is no objection, I assume everything's clear. If there is no question, I assume everything's fine. That's for the homeworks. However, for the quizzes, it will be in the last 10 minutes of the class. And the quizzes, I think, as I said, it will be in Fridays. So what you need to do, most likely the quiz sheet, I will provide it to you. So you will write your name, your ID, then start answering. So how to do the submission? You should have your cell phone, your iPad, tablet, any device. I expect everyone to have it. So make sure to bring it on the quiz day. So what you need to do, don't touch it, start answering. After the end of the quiz, or when you're done with the quiz, you need to submit your answer, then put your pen into the table, then take your phone and take a photo. You don't need to submit it as a PDF. As a photo is fine, as a PDF is fine, whatever more convenient for you. Then submit it on Canvas. But make sure to submit the right file, to submit, because if you submit, don't submit the wrong file. Sometimes can happen. Some people, some scenarios like having submitted homework of different course, submitted in the quiz. So please make sure to submit the right file. Before leaving the classroom, submit the right one and check it. Then you can leave the classroom. And when you touch your cell phone, you are not allowed to go back and modify your answer, even writing your name. You are not allowed to do anything. Just when you finish, and when you touch your phone, don't modify anything, don't write anything. Because sometimes I understand some scenarios can happen. Some student can share the answers, and you can say, "Oh, my answer is different," and then I can change it, which is this is not allowed. So please make sure modify your answer. Once you finish everything, submit, take a photo, and submit it to the Canvas. If you struggle with submission, or if you have any difficulties, I'm here in the classroom. Make sure to check this with me, or if you submitted the wrong file, let me know, then we can fix it. But once you leave the classroom, you will lose your rights for the submission. Don't say, I forget making the submission. That's your problem, you will get 0. Don't say, I didn't submit, or I submitted the wrong file, or I get any problem. So I was in the classroom, so if you have any difficulties, let me know before leaving. Okay? There will be an attendance, but the attendance will not be graded. So the attendance, I will take it randomly. Maybe sometimes I will take it based on the quizzes submission. So if I see these 2 students or this student didn't submit, this means he was not in the classroom, then I will consider him as absent. Sometimes I might take it here during the class. There will be no grades on it, but if there is a certain limit that you are allowed to have unexcused absence. After that, I'm not sure, I will report this to the department and they will take care of this. For the exams, exam 1 and exam 2, you can the submission will be as any normal exam. Don't take any photo, don't submit it through the system. The submission will be as usual, like hard copy. It will be as any regular exam. Now let's go back to the course syllabus. Okay, as I said, like attendance is mandatory in this class, and it's very important. At the end of the class, no, it is very important. Please don't leave the classroom until the instructor is done. I will try my best to finish on time. Sometimes, like leaving or trying to move before the end of the class, maybe in the last minutes, this will confuse, or this will affect the instructor, will affect the other classmates. So we want to make sure that sometimes the last minute will be very important, especially like for the quizzes or for the exams. So sometimes I can say you need to focus on this example or focus on this part because it will be in the quiz. And this sometimes can happen. So please make sure to pay attention to every detail. Using the electronic devices, if you need to use your iPad, tablet, or your computer, that's fine. You can use it during the class, but of course during the exams you are not allowed, and during the quizzes. But during the class, that's fine. The homework, again, you can submit them on Canvas as a PDF file, and make sure to submit it on time. You can have the startup. For every homework there is a startup time and due dates. There will be no late for the homeworks, and it will be grading as anonymous peer review. So you will not know who is grading your exam or who is grading, your homework. And I'm intending also to publish the answers, so you don't need to worry about the answers, how you grade. And the quizzes, again, it will be in Fridays. The lowest quiz score will be dropped. So this can be helpful for you. The quiz will be in the last 10 minutes of the exam, of the lecture. That's what I'm willing. Sometimes if there are some situations, if I make it in the middle or in the first 10 minutes, it can be any time of the lecture. But what I'm willing to make it in the last 10 minutes.
I have a question.
Yes.
How many questions is like an average quiz?
For the quiz?
Yeah.
Most likely it will be like one. It depends on how's the problem. If it is like long problem, it will be one.
Okay.
If there are some, it can be 4.
Okay.
So it depends. But most likely I'm willing to make this quiz to be done within 5 to 7 minutes. You can done with this. So the other 3 minutes is just like for you extra to think more about it. The quiz again sheet will be provided to you. In case of the quiz sheet is not provided, you need to have your own sheets. But I'm not willing to do that. I'm willing to give you the quiz sheet, so it should be fine. But in case if I need to change this plan, I will let you know. So this is written in the syllabus in case if I need to change some plans. Makeup quizzes will be given only in case of excused absence. So there is a section called excused absence in the syllabus. We will go through this now, then it will be helpful how to make this. In case, again, if the quiz sheet was not provided, how is the paper format? It will be as shown here. But this is in case if I switch to say, let's make the submission in person, let's make this, the submission in paper, or if we need to make it in your own paper, not printed, or if it's not being provided. Unannounced quizzes. The instructor reserves the rights to give unannounced quizzes at any time during the course, even without being noticed, because it's unannounced, and it can be considered from the weekly quizzes. In case if this needed, this might happen. So the instructor has the right about this. The exams, there is exam 1, 2, and final exams. These exams will be closed note, closed book. The same also for the quizzes, closed note, closed book. Closed notes, closed book. The final exam is cumulative, but there is a handwritten 3 by 5 inch note card will be allowed in each exam, and must be handwritten. So in case if there are some formulas that you need, for example, to write, you are afraid to forget. For example, like flip-flops, sometimes some people can forget these equations and you can write them here. Or sometimes the idioms in algebra, then you can write them. So you can write whatever you want or whatever you need in the note card, which is 3 by 5. It must be 3 by 5. Make sure to write your name, your ID or email on it. Handwritten is not printed. Printing is not allowed. And you can use it in each exam, double-sided. It can be fine. Makeup exams will be given as well, only if and only if an excused absence for. Most likely, as I said, the exams and the quizzes will be on Fridays. In case if you have any excused absence, it will be in the following Monday. So Friday, it will be Monday. So if for some reason you have an excused absence on Friday, make your preparation and be ready to take it on Monday at 11 a.m. for the exam, makeup exam, or the makeup quiz. In case if this time does not work for you, or if you still be excused during this time, then we can set up something later. Or if this time does not work for you, then we can coordinate with this to make it a different day. So how to make an excused absence? You need to document this through the engineering student services. So by following these procedures. So every time if any student send me an email and tell me, okay, I'm excused or I have some emergency, I cannot come. So the first step that I will tell you, please go to the course syllabus, go to the excused absence portion and follow the instructions there. So what I encourage you, before even emailing me, submit an excused absence there, then you can send me an email, that's fine. So this is the first step that will be, should take into consideration. So you need to submit this, make the reason, document the reason. Then the engineering student services will process this and verify these documents. Then the assistant dean will determine if this accepted or not. Some of the excused absence, it can be up to the instructor. Sometimes the ESS will tell you it's up to the instructor. We cannot determine. In this case, if I find like you really have an excused absence, then I will take care of this and I can consider it as an excused absence. So I'm every time on your side. Even if the ESS refuse this and you still think that it's still an excuse, then that's fine. For example, if you have a job interview and this is very important and you cannot change that time, and you have a quiz at that time, the engineering student service might refuse this, but I can be flexible in this. Okay? So once your excuse will be accepted, they will send me an email and tell me this student has an excused absence during this. Okay? Computer usage, make sure to check Canvas on email account, most likely Canvas, because here the course content in Canvas, at least once every 24 hours. So I'm not willing to make any big or we call it sudden change, but some change can happen. So please make sure to review this, to review the announcements. If there's, for example, a change in the homework due date or change in the quiz date or something like that. I'm not willing to do that, but again, some situations can happen. Calculator policy, of course, no calculators are allowed either in the exam or the quizzes. Cell phone, electronic devices. Make sure during the exams, quizzes, don't use this. The only thing that you can use cell phone again when you need to submit the quiz. When you need to submit the quiz, at that time, you are not allowed to write anything. So it looks like you already turned back your quiz, but you are in the other process, which is taking a photo and submitting. Academic accommodation. So if you have any accommodation, I encourage you to submit the accommodation request through the Office of Accessibility as soon as possible. You know the first quiz will be next Friday, which is May 26th. So please make sure to submit it as soon as possible. So because we need to make a meeting, there are some other steps, procedures that we need to do. So if you have any accommodation, please make sure to submit it as soon as possible. Okay, so the assignments here I mentioned like stable, but most likely you don't need because it will be the submission of the homeworks will be on Canvas. So make sure to submit this as a single PDF. So instead of the word stable, you submit it as a single PDF for the homework. While for the quizzes, if you submit it as because it will be one page, you can submit it as a photo, that's fine, or as a PDF, whatever more convenient for you. Okay, the makeup policy, I mentioned like it must be an excused absence. Classroom mask policy, I think it's no longer exists. I think I need to remove this section. For the COVID absence, now the COVID is no longer considered as a pandemic. It's like any regular disease like flu or any other sickness. So if you have COVID or if you have flu or any other sickness that can be contagious to other, please don't come to the class. Please let me know, even if you have any exams. Don't worry, your health and our health is our priority. So please make sure, don't come when we can make any like the makeups, we can make it so you can catch up with the class as easy way. In case if the instructor like being sick for some reason, then you will see the classes or the lectures will be published online on Canvas. So in case of this thing happen, then you will see the recordings on Canvas. Okay, so again here you will see the course summary, the quizzes, the exams, the homeworks. So you will see them as shown here. Then let me go through step by step here. Assignments, I already explained homeworks, exam, quizzes. Exams, you will see it here, but you don't need to submit anything. Even if the system Canvas says no submission, that's fine because it's on paper, not on online. Panopto recordings, I'm willing to record the classes. And you see now it's recording right now in progress. So today's lecture is recorded, and I'm willing to record all of the classes. So in case, if for example, someone have an excused absence, you can see the recordings here. In case if you need to go back to review something, like if maybe that lecture was difficult or you need to review something, or that example was hard, something like that, or maybe when you are studying for the final, you forget one topic, you can go back to the recording at any time. So it will be more flexible for you. But at the same time, I don't want this recording discourage you from coming to class. So please make sure to attend the class. If I find a lack of attendance or very low number of attendance, then I might remove the Panopto recording or disable this feature. I still record these classes, so I may disable this feature. If anybody have an excused absence, I will send you the link. Otherwise, I will not. I'm not willing to do that. I'm willing to make it open to anyone. But in case if I find a lack of attendance, this will be a different scenario. Okay, so here in files, you will see some notes here. So there are, the first thing is to fill in notes. To fill in notes, these are the notes we'll cover during the class, and these notes without answer. So for example, here. So it has some empty spots, so you need to fill them. While, so what I encourage you, like when you look at these notes, you can fill them with me. So if you like writing with the instructor, then you can do this, which is, I'm gonna go through these notes and write the answers, so you can write them with me. You can either printing them or have them in your iPad or tablet or your computer and fill this with me. So you will see most likely these notes as shown here. At the same time, you will see a completed notes. The completed notes here, the notes with the answers. So if you don't like writing and just want to pay attention without doing anything, you can see the answers here. So these completed notes with the answers. So you will see the answers and everything's fine. Okay? Sometimes I think when we go to kernel maps, these answers will be different than what I will go through, because dealing with kernel maps in this textbook different than the other book. So when I write the completed notes, I was using the other way, not this way in this textbook. So this will be different, something different. I will discuss this during the class later. Here it is about the all access textbook, and This is the course syllabus. You will see it here in PDF as a PDF file. And you will see as well the homeworks. You will see the homeworks answers. Now, I'm not publishing them. It's unpublished. But you will see the homeworks answers here. So basically, you after the deadline of the homework, these answers will be available to you. Then, when you need to when you need to do the grading, because you will be assigned to grade the homework, you can find the answers here, for example. Then you can grade based on the answers for all of the homeworks. Okay? So they're already uploaded, but you didn't have an access to it. You didn't have an access until the end or until the deadline passed. After the deadline passed, these answers will be published, and you are not allowed to do any late because the answers are published. Okay? While for the quizzes, you will see the quizzes answers here. I will publish them correspondingly. Now, there are no quiz answers. So, after the end of the quiz, I will publish the answer here. So you will have you look at the answer, so you can know where are your mistakes. So then make sure, please, to learn from your mistakes and learn from others' mistakes. So when you grade for your colleague, please be flexible and at the same time learn from his mistakes if there are some. Okay, now this is again the course syllabus, and here's the textbook, can be accessible from personal level. The attendance, as I said, I'm willing to take it randomly. Yeah, I think that's it about the course syllabus. Any questions about the syllabus? Is everything clear? Good. Now, let's go to the chapter 0. So you can go to Files to fill in notes. That's where we start. Then chapter 0. Okay. Okay, digital logic circuits. So what's this course and why this is important for us? Digital logic circuit is one of the basics or the foundations for the programming. Most likely in computer engineering and software engineering, computer science, electrical engineering. This is very essential because most likely, as we know, the computers are based on 0 and 1. I think many of you are familiar with this. Based on zeros and ones. So the digital logic, the digital means something, we call it discrete, it's not continuous, which is change. It can be either 0 or 1. And this is basically comes from the switch. Switch can be on and off, light on and off. And it can be also comes from software switch, and that software, or we call it soft switching. Not the regular switch like that we have here on and off. Sometimes the switching need to be very fast. It can be 10 kilohertz, which means 10,000 times per second. It can be 1 megahertz, which can be 1 million times per second. And this cannot be happening with the normal switch that we know. So how can we make this switching? The switching can be done using, we call it the transistor. So the transistor makes a revolution into the digital system, makes a revolution into the computer, as many of us know. So we know that in the early of 20th century, the computer was very large size, and they were using vacuum tubes. Then after that, they create by the semiconductor materials technology, and when they make this semiconductor materials invents the transistor, this makes a revolution, replace the large size vacuum tubes by a small transistor. And this transistor, by going more and more in deep in semiconductor materials, then we can make the transistor smaller size, until we see transistors in nano size. Then these transistors, now we can create computers in very small, like not like as a large computers now. We can have computers like in your cell phone, in your watch. You can see it even in nano size and small chip. So you can create this. And this happens because, again, what makes the revolution is the inventing of the transistor. Makes a big revolution. After that, the semiconductor materials invention. Then later, so it starts with hardware. So the first step or the first thing, which is in programming, was called hardware programming. And the digital logic circuit is based on something we call it hardware programming. So basically you will see we'll go through AND gates, OR gates, NOT gates, we'll go through adders, multiplexers, timers, counters, registers. All of these are based on hardware programming. So that's why this course is based on maybe the difficulty of this one, because later we will go through hardware programming. But we can see by the, maybe in the other advanced courses, you will go to microprocessors course, you will go to some like other, we call it high level languages. So when you go to high level languages, you will not build a very large circuit to do this program. You can do it in small one. So you can, for example, some examples that we will discuss in this class, we can do it actually using the Arduino. We can do it using a microcontrollers. So it can do the job in more efficient way than what we have here. But in this course, the nature of this course is to let you know about how we deal with this problem in the past, or how we deal with this in the foundation. So you need to understand how is the computer is working inside. Then after that, after understanding this, you have a clue how the system will work. So maybe you will not use a lot of these techniques later in the other courses. But what remains in your mind, which is the concept behind it. So you will see that for the high-level artificial languages, even like before high-level, there is something we call assembly languages. So the assembly language, you can use these hardware components to make the programming. Then after that, you can go to the C++, C#, Python. So you will see you can do the whole job with a small chip. Then you don't need to do all of these complicated design. So that's why this is called digital logic circuit. This course, because circuit design, which is based on hardware programming. However, there is also another hardware programming tool, which is using something we call it PLC, Programmable Logic Controller. And this thing is very well known in the industry, in the factory. So most likely, a lot of engineers are working on this, using the PLC programming. So the PLC programming also can be another tool for doing this. So, and there is also another way for doing the controller by using some control system devices, so it's control system techniques. This is in different course. Maybe some of you might, maybe if you are in software engineering, you will not take the control system. If you are in other majors, you might take this. So this control system also will teach you how to do some stuff in different ways. But what matters for programming is the digital logic circuits. And this is as a basic, as a foundation. Then you can go for further courses to make it more easier. So again, here, the main reason for this course is to understand these basics, these techniques. So when you go further courses, you know what's AND gates, you know what's counter, you know what's timer, even though that you will not use them because the computer can do this, the code can do this, but you know what's going on. I mean, in case if for some reason you need to build on your own device, you can build it. So, I think by the end of this, or the last lecture of this course, we will make a design for a traffic lights using a digital logic circuits. So this traffic lights example is, it will be kind of complicated. You will take a lot of time to do it. But in real life, they are doing it using PLC programming or using microcontrollers, so it will be more easier. This does not mean we are outdated. This means we found an easier tool that can do this job, even though this tool is becoming kind of, maybe this tool is what they were used to do it in old days, but it's very important to understand this. So we need to know, we can go like climbing the hill step by step. Okay? Now, in chapter 0, it's just like some concepts or some foundations. Digital systems. Okay, so digital systems, it can be something that's we can use it like using numbers. So there is the digital system most likely will be associated with something we call it discrete elements. Convert things, or we call it quantization or discretization. Convert this to discrete. So digitals, it can be system, it can include numbers, like digits, digital. Letters, we can convert letters to something we call an ASCII code. Then this ASCII code will be as numbers. Then pictures, we can convert the pictures to a small pixels. And these pixels, when each block will has its own value. So of each pixel, it has like a color, and that color it has a code, and that code will be as numbers. So basically we can realize that the digital system, we can convert this stuff to be as digital, as number. We can store the image, and the image will be at the end as a numbers or as a digital. The numbers, the words can be stored as digital. That's what we call by digital systems, which is creates everything converted to numbers or to make it discretized. So the digital systems can be a cell phone, digital camera, controllers, all of them are based on discrete system, which means discrete system, there is, we call it a switching frequency, or there's a frequency for it, which means how many switching period that I have per time, per second, like 10,000 switches per second, 20 per second, or 1,000 switching time per second. In other words, we are calling it as 10 kilohertz for 10,000 switching per second, or 1 megahertz for 1 million switching per second. So for any device, any electrical signal, it can be split into two. It can be as power signal, or it can be as data signal. The electricity that we have around us, it can be, again, one of these two, power or data. So power signal, which is the electricity in the wall outlets. The electricity comes from battery. So the wall outlet, for example, I know the voltage is 120 volts. I can predict it's, for example, AC signal, it's with frequency 60 hertz. Then I can know what it is. For the battery, for example, it provides a 5 volts or 15 volts constant. So I know what's the waveform, how this electricity looks like. However, this other signals is called data. This I cannot predict. This signal has meaning. So this shape of this signal will change with time. So for the power signal, it will be used for powering up devices. So the power signal will be used for powering up the cell phone, powering up the laptop, powering up the microphone, etc. However, the other signals that are called data, it have meaning. It has meaning. So how? For example, I'm talking here, and I need this talk to go through the microphone, and you can hear it. So I'm talking. Basically, my talk using the microphone will be converted from voice to electrical signal, and that electrical signal will be most likely in millivolts. This is small electrical signal. Then this electrical signal, in order to be processed, it needs to be digitalized or discretized. So this electrical signal needs to be something we call a quantization, make a level and make numbers for each signal. So convert my voice to electrical signal. This electrical signal will go as digital. After that, it will go through processing. Then it will go to amplifier, amplifying this signal, go to the speaker, and this speaker will produce my voice so you can hear it. And that speaker, you will see that there's a frequency for it. So the number of vibrations happen on the speaker, it will produce my voice. This one example of it. However, the microphone, sometimes I don't need to use the digital. I can use only the analog system. How? I can convert my voice to a small voltage and amplify this voltage to go to the speaker, and that's it. So sometimes I need to use digital, sometimes not. But I'm talking about like the data signal. The data signal, which are the signal that have meaning. So when you make a cell phone call, when you make a phone call, so the phone call using the waves. So your voice will go to the cell phone, and the cell phone will make the process, so it will go through the transmitter of the phone. The transmitter of the phone will go to the nearest tower, and the nearest tower will transmit it to the other towers of the, we used to call it cell, the cell of each area covered by, we call it a tower, or we used to call it a cell. It will go to the other cell of the receptions. For the receptions tower, it will deliver or transmit this to the, for example, your friend's cell phone. Then it will ring, then you can make a call. So the process is complicated, but it can be done within few milliseconds. So it can be done fast. The satellite as well, these signals matters for us. The satellite signal most likely will be in the frequency of it in gigahertz. And this signal will be very small, like in millivolts, sometimes nanovolts. Then this signal can be used, and this signal have meaning. So this, we call it data signal. So any signal that have meaning, data signal. The radio, AM radio, FM radio, all of these signals have meaning. Any connection with any communication system, these signals matters. Even if it's not wireless, if it's wired, like when you make a signal for the control system, like the thermometer. The thermometer is temperature the signal, like for the AC units, measuring the temperature, sensing the temperature. Then this temperature will be converted to electrical signal. Then it will go to the controller, and that controller will decide if it is too hot or too cold. Then let's run the AC and basis it's cold or hot, and we'll compare it with the reference signal. So these signals are not electrical. They are not used to power the device. They are not used to power up the satellite, not used to power up the AC. This signal just to control, and that signal again is data signal. So the data signal can be classified to different things. It can be as continuous controllers. So in control system course, they will teach you how to do it in continuous, and it can be discrete. And the word discrete, it has a lot of things. It can be discrete control, it can be digital control, it can be as digital logic, it can be as PLC, programmable logic controllers. So there are different ways how to do that. In this course, we will focus into the discrete and in the DLC, which is digital logic circuits, the hardware programming. So in data signal. So we will not worry about powering up the devices or about the other signal, because this will be in different courses, and this will be most likely more deep in electrical engineering major, not other majors. So this will be in different courses. So systems, for example, we can have some continuous systems, we can have some digital. Continuous systems like analog clocks, the old clocks, are continuous. So we have, it can move with time, then, or like the film cameras, the old cameras are, all of this in the past was continuous. Then, especially in the earliest of 21st century, like the digital system era, like everything becoming digital, so we got, instead of film camera, then we can have digital camera. So and also we have digital, different things are digital. Then this makes it more accurate, better resolution, and even when there is a noise, we can clear that noise using the digital system. So most likely, we will need to make it, convert everything to numbers or to digits, store this image as a digit, store this video as a digits. Then after that, it will be more easier. So if there is something unwanted, I can remove it easily. One of the disadvantages using the continuous mode, sometimes the error, sometimes the noise. So when we have like the temperature sensor, there is a digital temperature sensor, there is an analog temperature sensor. The digital is more accurate because eliminating the noise, eliminating the, there's like some accuracy on it. While for the analog, sometimes other factors can affect on it. So most likely, maybe if there is a resistor, it will change with heat, but sometimes some other factors can affect on it. So digital systems, we can make it, most likely the life around us is analog, not digital. how can we treat this as digital? For example, like I'm speaking, this signal when it goes to the microphone, it's analog. How can this be stored as digital? We need to something we call it digitalize this, or quantize this, or discretize this. Quantize or digitize. So we need to digitize this first, or convert this from analog to digital in something we call it ADC, which is analog to digital converter. So basically we need to convert this, then now it will be as digital. After that, converting this to digital, we need to make a quantization. After making quantization, then we can make this to 0 and 1. Using, for example, one example using the ASCII code, or using there are different other codes that we have. Let's take the example, digital thermostats. Digital thermostat most likely used to control the room temperature. So we have here the room temperature is being measured. Here's room temperature. So which is being measured using the sensor, the thermostat or thermos. So it will go to the sensor, then it will be as voltage signal. Now this signal most likely will be as analog. Something changing with time. So what we need to do is to something we call it quantization. So we can make levels and assign a value for each level. For example, I can say this is level 1, this is level 2, this is level 3. Then I can make something we call it sampling crates. So I can make a sample here, sample here, sample here, sample here, sample here, sample here. Then I can store a data as a sample. So the data will be stored like based on the samples and the levels. So this data will be stored, like for example here in this intersection, let me write also 1, 2, 3. This data will be stored, for example, this is in 2, this is in 3, this is in 2, this is in 1, this is in 2, 3, 2. So the data will be stored as dots here. Now you see that the waveform that I have here as sinusoid. But when I make this as digitalized, it will be as dots. And actually, in the digital system, the computer only can see these dots. It's not like us, we can see what's happening between the dots. The computer cannot see what's happening inside. You only see these dots. Now the question is are these dots the same as the actual? Kind of, right? Kind of. You see, like, we can see the trend of sinusoid. But now these signals have something, that's why when we make it digital, it will have some error. Now, is this error acceptable or not? If it is 99.999% accuracy, then that's fine. If it's 99, sometimes that's fine. If it is 50% accuracy, this is not acceptable. So, how can we make it more accurate? By increasing the number of samples. If we increase the number of samples, let me say that this signal is like this, and we make the samples like here's sample, here's sample, here's sample, here's sample. So it will be more accurate. When we make this sample, it will look like this, right? If we increase the number of samples, it will be more accurate to the shape. If we make the sample lower, like this. If we make it more than samples, like this. So the highest number of samples, the best, right? So when we realize that the largest sample is the best thing, and how can we achieve the largest sample, which is by increasing the frequency, the largest frequency. Or in other words, let's recall the computers in the old systems. Let's remember that there was like a slow processors, the processor of the computer like Core i1, i2, or even before the Core, like Pentium 1, Pentium 2, these were very old in the 80s, 90s. And when you also call like the software system based on 8 bits or 4 bits, then 8 bits, 16 bits, 32 bits. Now we have 32 bits and 64 bits. What does this mean? 34 bits, 62 bits. It means the number of samples to number of over number of bits. So when we have, for example, 2 power 2, which is 4, if 2 bits, you have 4 systems, 4 possibilities. But when you have like 3, 8 possibilities, and so on, 2 power 8 bits, then you can create more. So you can increase the sampling rates. So that's why when we create, by the hardware technology, make it the system can handle higher switching frequency, how can this be achieved? By the semiconductor materials technology has been growing up, then we can achieve fast processors. Then achieving fast processors makes more accurate devices. That's why when you look at the old images that come even by digital systems, it will be very poor quality. But when we coming out for the time, you will see the images are now more clear and clear. In the past, it was only SD quality of the images. Then, like when they invented the HD, we say, "Wow, this is great." Then after that, full HD, then 2K, 4K, 8K. We see that resolutions, what's happening. So with the technology, even that maybe after full HD, we cannot notice a lot like between 4K and 2K. They might, like when you look at it, it will be fine. But when you look at the large screen, it will matter. So accuracy will happen when explain the details, especially in large scale, like for example this projector. So when you have any cinema, like for example cinema screen, if it is in SD, it will be very poor. You will not see anything, and so on. So with this technology, or the invention of this technology, this makes the life easier. And what we see here, all of the improvement that happens, again, all of these technologies, even like the software engineering, like 30 or 40 years ago, it wasn't exist. Now it exists because all of these technologies happening. So the hardware comes first, and after that, when the hardware makes these revolutions, this encourages the softwares to develop more and more. So, and also there's still a lot of technologies are growing now. So you will see also in the future, especially in the semiconductor materials, you will see more faster. We are still not into the peak. We are still growing more and more. That's why we see the technologies are growing. Even go back 10 years ago. How was the technology? What will happen about the other 10 years? So you will see a lot of things going on. Okay, so for the digital thermostat, basically converting and sensing the temperature, converting this to the quantization, like make it as a levels, as shown here. Then it will go to the microprocessor, and we can compare this, or we can make the microprocessor, or we can use, for example, any other controller. Then we can compare it between the set temperature. So compares between current and set temperature. After that, if it is too cold, run the heater. So heater turned on. So it will send the command to the heater. How will it send to the command? If the heater, for example, is supporting the analog. So this digital will be processed, will be manipulated, these signals, and we need to convert this back to analog. How can we deal with this? Using something we call an analog to digital converter. We call it digital to analog. Return this back to analog. Digital to analog converter. So we need to return this, get it back again to analog, so it can be understandable by the device or by the compressor that I have. The compressor is only accepting only the analog device, for example. Now, right now, there are some devices that can accept digital, but let's assume that this device is only accepting the analog. So I need to convert this back to analog using something we call an analog to digital converter. How can we convert this back to analog? Let me talk about this signal. How can we convert this back to analog? Most likely, it will understand it like this. So it will hold. Go to this part, hold. Go to this part, hold. Go to this part, hold. Then hold. Go to this part, hold. Go to this part, hold. And hold. So it will go to this signal like this. Now, does this look like the original one? Not really. But the shape, we can see the trend of the shape, like it looks like sinusoidal. We can say like go up, go down, right? So the digital systems, if it is the switching frequency or the number of samples is low, it will act poor because it's very far away from the reality. But if we increase the number of samples such that the accuracy will be 98%, 99%, if we make it the number of samples like this, like a lot, so hold, go, pass and hold, pass, go and hold. So you will see this signal would kind of distorted, right? How about if the frequency number of samples was larger and larger and larger? You will not notice what's going on here. Then it can act, it can work fine. Okay? So we realize that the digital system is something good, something can help us a lot, and this really helped us in the past, and we are keep working on it. That's why we call it digital era. Like right now we are in the digital systems, digital era. How about the digital audio? So let's assume that we have this very old audio now. We need to convert this and store it. So basically, when the sound will go to the microphone, and it will be as analog signal. Like the same, like I'm talking, it will go to the microphone, it will be as an analog. Then there is a sampling rate, which is taking samples, the samples that I was talking before. The highest number of samples, the best for the system, of course. But we need to make sure the system is capable to do that or not. Does the hardware component that I have, can it handle? If it's yes, then okay. If it's no, and there is a hardware limitation. So this is also, you will notice this in the future when you are working with the programming. Even the program can do whatever you want, but there you have some limitations in the hardware limitations. So you still have some limitations to do that. So the sampling rates will make a quantization and make it samples like this. Then it will be go as numbers, and these numbers can be transferred using some codes to zeros and ones. So it will be stored like digital. Like, for example, the something that we know MP3. So we don't need to store it into these very old stuff here. So we can process it and we can run it at whatever we want. Again, like it's very similar when I say about the SD, HD, Full HD, 2K, 4K, 8K. What's the difference between them? Is the sampling rates. SD, for example, it was called as 480, HD 720, Full HD 180, and so on. So the highest number of bits, so you can say 2 power these numbers. 2 powered 480, 2 powered something like that. I'm not exactly sure. It's 1800. Then we see the highest number rates, the more clear image. Again, let's recall. Distorted sign, this is SD. More clear sign, this is HD. Perfect, Full HD, and so on. Again, the microphone converts the waves to electrical energy. Keep in mind, this electrical energy is used to not to power the device. Is used are used for data. Actually, one time, I read one of the people in the article mentioned that I can produce electricity from temperature, or I can produce electricity from waves, and it's free electricity. And when you read this article, he received these signals and used them to power up the devices. Or he received these signals and used them and say, you see, there's an indication. Use the digital multimeter. So, yes, you can get electricity from these devices, but these devices have low power, low current. So those are not efficient to power up the device. So we have waves around us, like a lot of waves, like the Wi-Fi. We have the cell phone, the satellite, the cell phone waveform, radios, AM, FM, everything. We have a lot of waves. we can receive all of these signals. You can make a receiver to receive all of these signals. But these signals in millivolts, in nanowatts. So this will not be useful to power up any device. It can be detectable. You can say, okay, I generate electricity from nothing. It's not generating electricity. Yes, there's electricity here around us. But this electricity is not enough to supply any device. So that's why some people trying to say, okay, we can generate electricity from nothing using just a receiver. And the real life, everything is an electricity. Like these waveforms, when you receive them, it will be electricity. So the AM, FM, all of this stuff. So microphone converts to electrical energy, which is called a transducer. Then it will be as analog signal. We need to convert this to digital using analog to digital converter, ADC. Then it can be stored to the computer. The computer cannot understand the analog. We need to convert this to digital. After that, it will be stored in the computer. It will go as, for example, binary representation as zeros and ones. Then for the computer, if we need to show them back or to hear them to the speaker, we need to make sure to put digital to analog converter, then put them to the speaker. So you can hear them. Even though they are stored in digital, you cannot put them to the speaker digital unless that speaker is can support this. So most likely, you need to convert this back from digital to analog converter. Now, if you have a poor analog to digital converter or poor processor, the quality of the audio will not be good. That's why when you go back or when you record a video, you can choose the quality. If you choose a low quality, this will not cover the whole details. Right? You will see some fuzzy in the image. When I record something, even try like to take a photo and take a photo and put the, for example, like these notes. Try to take a photo from the far, and when you take a photo, make it a low quality, and make zoom. Will you able to read this text? No. Make it as HD or full HD and take a photo. When you take a photo, you can read this. So you are taking the photo from the same position. What's the difference? The difference is high quality. What does this mean? High sampling rates. I'm storing more information. So the high sampling rates, the highest frequency, the highest quality means I'm storing more information. But when you are at low quality, it will take only the important events. Like the events that, okay, if it's very poor, I can know there's person here, but I cannot know the whole image. So this is the same when you have a speaker. Keep in mind that you have a high quality speaker to get a high quality voice, or a high quality, processor to have a quality voice. Otherwise, you will not be able to do that. For the quantization, like as I said, the signal will be depending on the sample. So for example, this sample at 5, this sample at 6, 7. So the computer will store these values, 6, 5, 6, or the quantize it. So this, instead of having this waveform, it will be stored into the computer as this number, this sequence. That's how the computer understands this graph. The computer will not know what's going on, will not know this graph in red. Have no idea. The computer only knows these numbers. 5, 6, 7, 7, 5, 4, 3, 1, 2, 5. This is the only thing that the computer understands. So now how these values will be stored. For example, we can convert this to any sequence, for example, using the 3-bit register. We can convert 5 to 101, 6 to 110, 7, 111, and so on. So we realize that for every number, even though that the computer will understand it as 5, 6, 7, 7, we need to convert it back or to convert it to binary, so 0 and 1. Because the computer is based on a switch, 0, 1, on, off, transistor, on, off. So 0 is off, 1 is on. So even though, again, it stored 5, 6, 7, 7, 5, 4, 3, 1, 2, but at the end it will be stored as 1, 0, 1, 1, 1, 0, 1, 1, 1, and so on. So, for example, in this register, it's registered as 3 bits. So it will take each 3 bits and take it into consideration. In real life, when the computer is not as 8 bit, you can go to the ASCII code. And the ASCII code, it will have, I think, 16 bits. I'm not exactly sure, but it will have a long format for each number, for each letter. So you can make your own message and convert this to a number, so it will be stored like this. Or, for example, this audio, first convert it to electrical signal, now do quantization as we see these numbers, then convert it back here. So the computer will store your audio, will store my voice, or store your voice as these numbers, as ones and zeros. How can we transfer this back to be here to the speakers, convert these numbers to this sequence, and convert this sequence to waveform, and put it to the speaker? Like do the reverse. Like instead of analog to digital, make a digital to analog converter. Okay, so just the thing which is, for example, 0, it can be as 5 volts, 1, it can be 0, sometimes negative 5 volts. This is one example of how can the computer understand this, basically by converting digital to analog. This is waves. Yeah, I think that's it for today. Next lecture, we will go from here. Digital circuit. Thank you.